Good morning, everyone. All right. So, students, please tell me if you got any doubts in chapters covered hitherto. ఇక్కడ వరకు జరిగిన టాపిక్స్ లో ఏ డౌట్ ఉందో చెప్పండి. We'll discuss that particular doubt so that we are comfortable with whatever is covered till now. Be it block and block, integrals, circular motion, pseudo force, projectile motion, any kind of motion, or graphs. I'm insisting that you ask any particular doubt you have got so that I'll go ahead with those doubts. All right. In the evening, we'll start the next topic. All right, students. Till then, you please recollect any doubt you have got. Till then, I'll continue with the numerical.
Can I explain projectile motion?
Yes, Omkar.
Can I explain projectile motion in questions?
All right. You want problems on projectile motion, or you want basic concept of projectile motion?
So basic concept.
All right. Basic concept. All right. In projectile motion, we have got when you have got an acceleration vector g, let's say acting downwards, or g effective is acting downwards. If I project a particle at an angle with g which is not parallel or anti-parallel, then what results is a parabolic trajectory. All right. In this case, what happens is I'll resolve my velocities horizontally and vertically. If this is theta, my horizontal component of velocity is v naught cos theta, vertical velocity is v naught sin theta. I don't have a component of acceleration horizontally. Horizontal component of g is zero because g is vertically downwards. So g cos of 90 is zero. So there is no acceleration in the horizontal direction, because of which horizontal velocity remains constant. So I split this motion of projectile into two independent motions. One is horizontal constant velocity motion and vertical motion under gravity. Combination of these two motions, superposition of these two motions results in a two-dimensional projectile motion. All right. So this is superposition of horizontal motion, horizontal rod moving like this, and a vertical rod moving under gravity with initial velocity of v naught sin theta, horizontal velocity of v naught cos theta. So superposition of these two results in a locus which is a parabola with the axis parallel to g bar. As I go on changing the angle, my path changes with the nature of the path remaining same, which is parabolic. So it again becomes a parabola with a different vertex and with a different axis, but still axis remaining parallel to the G bar. The range over here is given by V naught square sine 2 theta by G. Maximum height is given by V naught square sine square theta by 2G. Time of flight is given by 2V naught sine theta by G. So these are the three parameters which which give me the complete information about the parabola. Range R, range is nothing but when again the particle's velocity y component becomes zero, horizontal displacement covered in that time is range. Maximum height is nothing but the vertex, height of the vertex from the horizontal axis, x-axis is maximum height, or the height reached by the particle, maximum height reached by the particle is h max h, and time of flight is time taken by the particle from here to the point where the y coordinate again becomes zero, is time of flight, which is 2v naught sine theta by G. Now look at this, I've got v naught square sine 2 theta by G. If theta is again it is r for theta and pi by 2 minus theta. So if the angles are complementary, my range is equal. So if the angle is 30 degrees or 60 degrees, my range is going to be same. If the angle is 15 degrees and 75 degrees, range is same. So range is same for complementary angles. If it is theta and 90 minus theta, range is same for theta and range is same for 90 minus theta. The time of flight and height max will be different for both the thetas. All right, let's look at the equation of trajectory now. Equation of trajectory is given by, it is of the form y is equal to ax minus bx square, which is equal to tan theta x y is equal to tan theta x or x tan theta minus gx square by 2v naught square cos square theta. That's the equation of trajectory. Equation of trajectory can also be written as x tan theta into 1 minus x by r. Alternate form of equation of trajectory is x tan theta into 1 minus x by r. All right, let's look at an example. Where we'll find out range, time of flight, maximum height, and the equation of trajectory. Particle goes to the velocity of v naught root 2 at an angle of 45 degrees. I will determine the range. I'll change the markers. I will determine the range, maximum height, and time of flight. Horizontal velocity is v naught root 2 cos 45, which is v naught Vertical velocity is v naught root 2 sine 45, which is again v naught. Range is given by v naught square by g sine 2 into 45 by g. Maximum height is given by v naught square sine square theta by 2g. So sine square theta is how much? Sine theta is 45. Sine square theta is how much? What is the value of sine square theta, students, when theta is 45? Students, when theta is 45, what is sine square theta? Simple. Sine theta is 1 by root 2. Sine square theta is 1 by 2. So v naught square by 4g. And time of flight is 2v naught 2v naught sine theta by g. Now, what is the value of v here? V is the value of velocity of projection, speed of projection, which is v naught root 2.
So I think the range formula V naught square cos 2 theta by G.
Range formula is v naught square sine 2 theta by g.
Cos
And
theta.
maximum height formula is v naught
Cos,
square sine square theta by 2g. Time of flight formula is 2v naught sine theta by g.
okay.
All right. So sine 2 theta, that becomes v naught square by g. But what is v here? V naught root 2. So v naught root 2 whole square by 4g. T is equal to 2v naught root 2 sine 1 by root 2 by g. And my equation of trajectory becomes x tan theta, which is x minus gx square by 2 into v naught root 2 whole square cos square theta, which is 1 by 2. 2 gets cancelled out. I'll have x minus gx square by 2 v naught square. All right, if you can further simplify, you'll get 2 v naught square by g, v naught square by 2g, v naught root 2 by, 2 v naught by g. And the equation of trajectory becomes x minus gx square by 2 v naught square. So Ashrita, Bhavna, Omkar, Abu Sofyan, Amani, are you all following? Are you able to recollect the formulae?
Yes, sir.
Yes, sir.
All right. Omkar, have you understood what you what you wanted to ask?
Yes, sir.
All right. So if you have no other doubt, I'll go ahead with the circular motion problems or friction problems. I'll just take some random problem and start solving it. I've got a wire, circular wire, which is rotated about a diameter. with angular velocity omega naught. All right. And radius of the wire is r. All right. It is found then when you rotate like this, there is a bead which can move freely on this wire. It is found that it is at rest at a distance of r by 2. It is found that a bead is at rest with respect to the wire. All right, it's very important. With respect to the wire, it is at rest. With respect to the ground, it is moving in a circular motion in a horizontal plane like this. Because this is moving with omega, bead will also move with omega naught in this horizontal plane. Required to find omega square. Options are, first option is G root 3 by R. Second option 2G by R. Third option 2G by R root 3. Fourth option root 3G by 2R or G root 3 by 2R. Required to find omega square. Omega square is equal to how much? What's the value of omega square? The condition is the bead is found to be at rest at a distance of r by 2 from the axis of the ring. Sorry, axis of the rotation. Bead is found to be at rest with respect to the wire at a distance of r by 2 from the axis of rotation. Required to find omega square. So Ashrita, Bhavna, Mani, Abu Sofyan, Omkar. We have done this problem. We have taken this angle to be theta till now. But instead of theta, I've given you this as r by 2. So how do you do this? All you have to do is draw the FBD, choose a reference frame, draw the FBD and write F is equal to MA. But I told you, whenever you have a rotating reference frame, it is easier to do with the concept of pseudopoles, applying the concept of pseudopoles. So let us choose the reference frame to be my rotating ring, circular ring, which is rotating about the diameter with the angular velocity omega naught. So with respect to that ring, I have normal reaction. This angle is how much? 60 degrees. Pseudo force is m omega square r by 2. Gravitational force is mg. All right, it's not weight, it is gravitational force. Remember, I've told you before as well. There's a difference between weight and gravitational force. It is not weight. Weight is not mg. All right, weight is what the normal reaction is. Weight is what the weighing machine measures. But gravitational force is given by mg. Force exerted by Earth on the particle is mg. Real forces are n and mg. There is a pseudo force, additional pseudo force, and the acceleration is, this completes the FBD, and acceleration is 0 with respect to the ring. So now what I do? N cos 60 minus m omega square r by 2. N cos 60, which is n into 1 by 2, minus m omega square equal to 0. Now I take the vertical component of n. N sin 60, which is n root 3 by 2 minus mg equal to 0. I can write this as n equal to m omega square r by 2, n equal to mg. Sorry, n root 3 by 2 as mg. I divide these two, n gets cancelled out, half gets cancelled out. So I'll have 1 by root 3, m gets cancelled out. 1 by root 3 is equal to omega square r by 2g. So omega square is 2g by r root 3. Check if this is correct. All right, I could be wrong in this calculation. Check if this is correct. Students, is this correct? Is omega square 2g by r root 3? Check if I have done this correct. Bhavna, Ashrita, Omkar, who else do we have here? I cannot see all the names. Just a second, I'll just check all the names. But check if this is correct, students. I've written normal reaction equating to component of normal reaction, horizontal component of normal reaction equating to pseudo force, vertical component of normal reaction equating to the gravitational force. I divide these two equations, I'll get omega square. Check if this omega square is correct. Is the simplification correct?
Yes, correct.
It's correct? All right. So option is all right. This is from previous mains question from 2019. All right, it's a mains question. It's a purely single concept question. There's no multiple concept here, and that's what happens in mains usually. You may have two concepts mixed or multiple concepts or two concepts రావచ్చు, but there's no two concepts here. There's only one concept of circular motion, which is uh, applied here. All right, let's go for the next question. Any doubt over here, students? Is the question fine? Is the solution understood? All right, let's look at the next question. I'll send a pic to you. I'll send some pics. Let's solve these questions now. Students, you have to participate. Otherwise, I'll skip the question and go for the next question. All right, read the question now. I'll send the pic. Hope you have received the pic. Here's a good question, students. Sleeve doesn't slip on the rod. Have you read the question? Say yes or no. It's a good question involving multiple concept of friction and static friction and circular motion. Is it omega or omega naught? Omega. This length is how much? Length is L. Let us draw the FBD. Choose a reference stream, draw the FBD, write equations of motion. All right. Any NLM question? That's the strategy. Choose a reference stream, draw the FBD, MAD, and write the equation of motion. Write Newton's second law of motion. All right. Let's do it with both the reference stream from ground as well as rotating reference stream, inertial as well as non-inertial reference stream. So using this circular, rotating reference frame, my FBD's normal reaction is towards left, pseudo force is towards right, FP, which is equal to m omega square L. Gravitational force is downward. What kind of friction is acting? Static friction, because there is no relative motion between the bead and the rod. It's static friction. How do you decide the direction of static friction? You presume everything is frictionless and see in what direction it is tending to slip. If it is frictionless, it will tend to slip downward. Friction will act upwards. And limiting value of friction is mu times n. So for it not to slip, my F should be less than or equal to, F should be greater than or equal to mg. So limiting value of friction should be greater than or equal to mg. So mu times of n should be greater than or equal to mg. So mu times of n, what is n here? N is equal to m omega square L. M omega square L is equal to mg. Limiting value is this one. M gets cancelled out. So omega is equal to g by mu L under root. So is the option there? Yeah, option A. Required to find omega such that it doesn't slip. For it not to slip, my friction should be limiting value of friction should be able to counterbalance mg. Right? So mg should be less than the limiting value. If that is less than the limiting value, what is the value of friction? It's equal to mg, equal to the external force. But what if limiting value is less than mg, it will start slipping down with some acceleration. So for it not to slip, my limiting value should be greater than mg or equal to mg. When it is equal to mg, it is tending to slip. So that limiting value, that critical value of omega is mu times m omega square L is equal to mg. Omega is equal to root of g by mu L. Check if this is correct, students. Check if this is correct. I mean, the simplification is correct. Mu times n should be greater than or equal to mg. N is m omega square L should be equal to mg. M gets cancelled out. Omega is root g by mu L. Yeah, that's right. All right, let's do this from the ground reference frame. All right, what is MAD over here? MAD was very simple, so I didn't draw it. Acceleration is 0. With respect to this rotating wire, rotating reference frame, particle is at rest. So acceleration is 0. Now let's do this from the ground reference frame. All right, everything should be same. You will not have a pseudo force here, but MAD will be different. So what from ground reference frame, inertial reference frame G, friction, mg and normal reaction will exist. Pseudo force will not exist. Rather, you will have a centripetal acceleration of centripetal acceleration of omega square L. So FBD and MBD is now complete. So N is equal to m omega square L centripetal force is equal to mass into centripetal acceleration. F should be less than, FL should be less than or equal to, sorry, FL should be greater than or equal to mg for it not to slip. Mu times n is equal to mg. M gets cancelled out. Omega square is equal to g by mu l. Omega is equal to root of g by mu l. You got the same answer. Everything is same. Equations of motion are the same, but the interpretation is different. I've got n minus omega square L equal to 0 in the previous case, which meant net force is equal to 0 because particle is in equilibrium. But here, centripetal force is resulting in centripetal acceleration. There's a cause and effect relationship here. Cause is n, effect is omega square L. So n is equal to mass times omega square L. This condition is again the same in the previous reference frame and this reference frame, in inertial and non-inertial reference frame. MAD is different here. Mass acceleration diagram is different. Look at this. In the previous case, acceleration was 0, so I didn't draw it. I didn't draw the acceleration over there. But here you have a centripetal acceleration. From ground, particle is observed to go in a circle like this. Circle of radius L in a horizontal plane. All right. Sorry.
Okay, sir.
Okay. All right. Let's select another problem. Others, if you have got any doubt, please ask now itself, because in the evening we'll be going out with the syllabus and we'll not have time for revision the way we have it right now. All right, here is a multiple correct question. Students, next week you're going to have advanced pattern where you'll have multiple correct questions, numerical and single correct questions. I mean, you could have advanced pattern. It could be matrix matching, it could be multi-correct, it could be paragraph or comprehension, or it could be numerical. But you're having only mains pattern till now, but you will have 1 week advanced as well, advanced pattern as well. And the syllabus is going to be complete syllabus till whatever is covered till now. All right, we have dealt this while discussing curvature. So you can try this question. I'll give you a minute. Think about it, students. Think about the curvature. Think about the pseudoforce. Think about the, or if you're thinking in terms of ground frame, think about the centripetal acceleration and the centripetal force. If you're thinking in terms of, I mean, with respect to the reference frame, rotating with respect to the, non-inertial reference frame, then think in terms of pseudo force as well. You will have all the real forces and an additional pseudo force. All right, we have done all these things, but right now you have to apply all these things, all that you have learned to one particular question. In fact, we have dealt this similar question while dealing with curvature. All right, this question should not be that difficult to you. And it's a multiple correct question. I'll give you a minute, students. Please think about it. But there's a small correction over there. It is not moving with constant velocity. The particle is moving with constant speed. All right, there's a small correction in the question. The particle is moving with constant speed, not with constant velocity. All right, if it were to move with constant velocity, it would move in a straight line. It would not be a curved path. All right, so there is a error in the question itself. You will not have such errors in the final exam. All right, don't worry, that will be technically perfect. And I will also try to avoid such errors in our weekend exams as well. Looking at the diagram, I took a pic and sent it to you. So normal reaction exerted on the body by the path is greatest at NB, at point B. How can you say that? How do we decide what normal reaction is going to be depending on the curvature? We have discussed this in the last class, not in the last class, a class before last class. Let's have got a curvature like this. Radius of curvature is R. Particle is moving with speed V naught. Normal reaction is N. Gravitational force is mg. So looking at this from ground frame, I'll have a centripetal force which is v square by r. Sorry, centripetal acceleration which is v square by r. So FBD and MED are complete. So I can write N minus mg equal to mv square by r. So N is equal to mg plus mv square by r. So now look at this, students. You have an additional term being added to the gravitational force. So normal reaction is definitely more than the gravitational force at a point where the curvature is, I mean, you're going down with the curvature being cup being directed upwards. All right, cup open upwards. But let's say you got a curve like this, downward curve, cup open downwards, and it's moving with constant speed v naught. So I'll have mg normal reaction, centripetal acceleration is v square by r. So I'll write again from ground frame, MAD and FBD are complete. Mg minus n is equal to mv square by r. So n is equal to mg minus mv square by r. So I've got an additional term here which is being subtracted from gravitational force. So my normal reaction will be less than the gravitational force here. So normal reaction will be least in this case and maximum in this case. So at C it's going to be least, or at A and C it's going to decrease. At B and D it's going to be greater than mg. At A and C it's going to be less than mg. At B and D it's going to be greater than mg. Now look at this R. Radius of curvature at B is less than the radius of curvature at D. So the curvature is more here at B. Curvature is more. Radius of curvature is less, so curvature is more. It is being taken. It's taking a sharp turn. Here it's taking a smoother turn. Comparatively, this is a smoother turn than this. So curvature here is less. Curvature here is more. Radius of curvature here is less. Radius of curvature is more. Curvature is inversely proportional to radius of curvature. Curvature K is equal to 1 by r. 1 by radius of curvature. So here normal reaction will be the maximum. Here normal reaction will be the least. Think about it. I'll give you another minute to think about it. If you have got any doubts, you can ask me again. Is it clear? Students, is the question clear? So first option is right. How about the second option? Normal reaction exerted on the body by the path is least at NC. Normal reaction is greater than weight at B. Normal reaction is lesser than weight at A and D. At A is definitely it is lesser than gravitational force. There is again an error supposed to be weight there. Weight is a technical term used for the normal reaction measured at a particular point. All right, remember that. It is wrong to say mg is weight. Mg is not equal to weight. It is only on ground. When n is equal to mg, it is only on ground when the surface is not moving and the block is at rest on the surface of ground. But n is what is weight. If I keep a weighing machine at B here, so what is measured by weighing machine is normal reaction, and that is called weight. All right, technically that's called weight. So be careful. Don't be confused. Looking at the term weight being used sometimes incorrectly for mg. All right, mg is not weight. Mg is gravitational force exerted by Earth on the particle. Weight is the normal reaction experienced by the particle, or the weight is the reading of the weighing machine, which is equal to normal reaction measured felt by the particle. All right, look at the option. Now tell me the options. Which are the options correct? A, B, C, and D. A is definitely correct. Look at B, C, and D. Bhavna, Ashrita, Omkar, Vignesh. Vignesh, you're late today. Amani.
Yes, sir.
Vignesh, are you following?
No, sir.
Sorry?
No, sir.
No. All right. I sent a question in the group. Read the question, see the second question, and answer the it's a multiple correct question. You have to choose all the correct options out of the four. A is definitely correct, which I've deduced just now, concluded just now. You have to think about B, C, and D along the same lines of reasoning which I've used for A. In fact, I revealed the answer a while ago, but if at all you haven't listened to that, you can again try which of these four options is correct. Which among these four options are correct? All right, I'm giving you a hint again. There are more. It's a multiple correct question. Multiple options correct. A is definitely correct. You have to think about B, C, and D along the same reasonings applied for A. ఇక్కడ ఏమవుతుంది radius of curvature here is least. So curvature is maximum. Radius of curvature over here is maximum. Curvature is least. ఇక్కడ it's a downward curve. Downward curve. So normal reaction on the downward curve is lesser than mg. So ఇక్కడ less than mg, less than mg, greater than mg, greater than mg. Now think about B, C, and D.
C.
Is B correct? What is B? Normal reaction exerted on
C,
the
sir,
body by
C.
the path is, sorry?
C.
C is correct. Normal reaction is greatest than weight at B. Yeah, that's right. That's good. C is correct. And how about B and D? Students, make it quick. Running out of time.
Yeah, so the B option is not comparing with the gravitational field, it's comparing with the path. And the D option is wrong, sir. It could be greater than the weight at the A and D. So we don't choose the both option and we will choose the C option C.
Option C is correct. Option A is correct. Option B says normal reaction exerted by the body on the path is least at NC, at C. Definitely, that's right. No, at C, it's least. Look at this. There is a term which is being subtracted from mg whenever you have a downward curve. So curvature is more or curvature is less. Normal reaction is lesser than mg definitely, but because the curvature is more here, so normal reaction will be even more lesser than compared to A. So A and C is less than mg, but it's least at C. So C is also correct. I mean B is also correct. Option B is correct. But option D says normal force is lesser than weighted A and D. At A it is definitely less, but at D it is greater. So option D is wrong. So correct options are A, B, and C. All right, let me check the answer. Let me check the key. Yeah, that's right. A, B, and C. All right, I'll send another question to you along the same lines. It is a previous Iit-Jee question, advanced question. You see how simple it is. It's just conceptual question. I'm sending you the figures. The question is, you have to determine the normal reaction at the extreme point of the curve. All right, at the extreme upper end of the curve. It is moving with constant speed. It is frictionless. Particle is moving with constant speed. You have to measure the normal reaction. You have to compare the normal reaction and say at which of these curves is the normal reaction maximum. At this point he's talking about. At this point. All right, it's gravity is down the plane. Sorry, into the plane. I'm looking at the particle from above. This particle is going with constant speed. Obviously, it will go with constant speed because there is no tangential force on it. There's no friction over there. Normal reaction doesn't affect the tangential component of the velocity. Normal reaction only helps in making the particle take a turn. You have to decide whether normal reaction is maximum here, or in the other two pictures. Where is the normal reaction maximum? Normal reaction will be maximum when the curvature is maximum or the radius of curvature is minimum. See, these are two different things. Curvature and radius of curvature are two different things related inversely proportionally to each other. Radius of curvature is more, curvature is less. Curvature is more, radius of curvature is less. So for normal reaction, if curvature is more, Normal reaction required to make it turn, make it take a sharp turn is required is more. So normal reaction ఎప్పుడు ఎక్కువ required అవుతుంది when you have to make a particle make a sharp turn. You have to make a particle take a sharp turn. అప్పుడు normal reaction required is more. So now think about it and tell me where is the normal reaction maximum. In this case, or the other two cases. You have the figures with you. I'm not drawing all the figures on the board. Figures are with you in the group. Bhavna, are you there today?
Yeah, sir.
All right, you are very silent today, so I thought you're not present. All right, think about it, students. So normal reaction ఎప్పుడు ఎక్కువ ఉంటుంది when you have taking a sharper turn. This is sharper than this one. So normal reaction is maximum here. So out of all the four, normal reaction ఎప్పుడు ఎక్కువ ఉంటుంది where the curvature is more or the radius of curvature is less. ఇక్కడ radius of curvature more ఉంది, ఎక్కువ ఉంది. ఇక్కడ radius of curvature తక్కువ ఉంది. So normal reaction over here required to make it, this is sharper turn than this. So ఇక్కడ normal reaction ఎక్కువ required ఉంటుంది. So here is maximum, here is least. Least last fourth option లో ఉంటుంది. Maximum is in the option A. All right, students, you have got a math class coming up. Please join the next session. Thank you all.